Okay, I'll assume everybody's back from a break. Okay, this is actually the setup of the experiment you would do if you did this one in the laboratory. So in one beaker, you would put some zinc sulfate, the other some copper sulfate, a strip of zinc metal in the zinc sulfate, and a strip of copper metal copper sulfate, and then you'd have a salt bridge between them. Actually, you'd use kind of some thread that's been dipped in some potassium chloride, and then this would be hooked up to a voltmeter. Now, they've done you a giant favor because if you look below, they've actually given you the two half reactions. And you notice that would agree with your chart because zinc is a better pusher than copper. And they've also done you a favor by showing you the overall reaction. Okay, here comes the calculation part for you. Okay, so in part A, you would make the zinc solution 1 molar and the copper solution 1 molar also. Okay, now what we want you to do then in this blank space here is to figure out the theoretical voltage of that cell. Okay? So I guess the best thing would be to write the Nernst equation in and plug the numbers in, I guess, okay, and then get the theoretical voltage. Now, I kind of pretended like you actually did the experiment, and so I wrote down a typical voltage a student would get. That would be the 1.07 volts. Then I want you to do a percent error calculation. Okay, so in case you've forgotten percent error, the difference between the theoretical and the experimental divided by the theoretical times 100 would give you the percent error on how well your experiment did. Now look at part 1b. Okay, so now we want you to change the concentration of the zinc from 1 molar to 10th molar. Keep the copper 1 molar. Again, use this space here, plug into the Nernst equation, and calculate in theory what the voltage should be. I've given you, if you did the experiment, I gave you a typical voltage a student would get. And again, I want you to calculate a percent error. Okay. And by the way, you might be thinking about this while you do this, and that is, how should the voltage change from part A to part B? Okay, you should kind of reason out if that makes sense or not. Okay, now look at part C. So now again, we've done some changing. We've made the zinc back to 1 molar, zinc ions 1 molar, but now the copper is 10th molar. Okay, so we want you to use the Nernst equation in this space here to calculate in theory what the new voltage should be. And I've given you, if you did the experiment, a typical voltage a student would get 1.05 volts, and again, calculate a percent error. Okay, so I guess I would say the key thing this experiment is good for is give you some practice in the Nernst equation itself. Okay, one more part I want you to do, and that is post-lab question number 1. Okay, so what do they suggest you do? It says sketch and label well with movement arrows the processes occurring in the standard Daniell cell. That's the name of the cell we actually have here while it is operating. Note that the electrode reactions produce and consume ions and electrodes. Okay, well here's essentially what I want you to do. I want you to draw a drawing of the 2 beakers, the 2 cells, and then I want you to answer the 7 questions that I taught you before. So let me go over them with you. So I want you to draw an arrow showing electron flow, then write down the 2 half reactions, write the total reaction. Don't bother calculating the E0 because you already done that part. Let's see what else I want you to do. I want you to label which beaker is the cathode, which is the anode, show the ion flow, show arrows for the ion flow, and the last thing is I want you to label the posts, one positive and negative. Okay, so that would be good practice on those 7 questions I taught you and analyzing the cell. Okay, and this will be due in 10 minutes. Not just kidding, I'll give you a week to do it. Okay, so let's make it due next Tuesday. So anytime next Tuesday, send me your results on experiment number 13.